In our previous lesson, we saw how we can evaluate prefix and postfix expressions. Now in this lesson, we will see an efficient algorithm to convert infix to postfix. We already know of one way of doing this. We have seen how we can do this manually. To convert an infix expression to postfix, we apply operator precedence and associativity rules. Let's do the conversion for this expression that I have written here. The precedence of multiplication operator is higher. So we will first convert this part, b asterisk c. b asterisk c will become b c asterisk. The operator will come in front of the operands. Now we can do the conversion for this addition. For addition, the operands are a and this postfix expression. In the final step, we can get rid of all the parentheses. So finally, this is my postfix expression. We can use this logic in a program also, but it will not be very efficient, and the implementation will also be somewhat complex. I'm going to talk about one algorithm which is really simple and efficient, and in this algorithm we need to parse the infix expression only once from left to right, and we can create the postfix expression. If you can see, in infix to postfix conversion, the positions of operands and operators may change, but the order in which operands occur from left to right will not change. The order of operators may change. This is an important observation. In both infix and postfix forms here, the order of operands as we go from left to right is, first we have A, then we have B, and then we have C. But the order of operators is different. In infix, first we have plus and then we have multiplication. In postfix, first we have multiplication and then addition. In postfix form, we will always have the operators in the same order in which they should be executed. I'm going to perform this conversion once again, but this time I'm going to use a different logic. What I'll do is I'll parse the infix expression from left to right. So I'll go from left to right looking at each token that will either be an operand or an operator. In this expression, we will start at A. A is an operand. If it's an operand, we can simply append it in the postfix string or expression that we are trying to create. At least for A, it should be very clear that there is nothing that can come before A. Okay, so the first rule is that if it's an operand, we can simply put it in the postfix expression. Moving on, next we have an operator. We cannot put the operator in the postfix expression because we have not seen its right operand yet. While parsing, we have seen only its left operand. We can place it only after its right operand is also placed. So what I'm going to do is I'm going to keep this operator in a separate list or collection and place it later in the postfix expression when it can be placed. And the structure that I'm going to use for storage is stack. A stack is only a special kind of list in which whatever comes in last goes out first. Insertion and deletion happen from the same end. I have pushed plus operator onto the stack here. Moving on, next we have B, which is an operand. As we had said, operand can simply be appended. There is nothing that can come before this operand. The operator in the stack is anyway waiting for the operand to come. Now at this stage, can we place the addition operator in the postfix string? Well, actually what's after B also matters. In this case, we have this multiplication operator after B, which has higher precedence, and so the actual operand for addition is this whole expression B asterisk C. We cannot perform the addition until multiplication is finished. So while parsing, when I'm at B and I have not seen what's ahead of B, I cannot decide the fate of the operator in the stack. So let's just move on. Now we have this multiplication operator. I want to make this expression further complex to explain things better. So I'm adding something at tail here in this expression. Now I want to convert this expression to postfix form. I'm not having any parenthesis here. We will see how we can deal with parenthesis later. Let's look at an expression where parenthesis does not override operator precedence. Okay, so right now in this expression, while parsing from left to right, we are at this multiplication operator. The multiplication operator itself cannot go into the postfix expression because we have not seen its right operand yet, and until its right operand is placed in the postfix expression, we cannot place it. The operator that we would be looking at while parsing, that operator itself cannot be placed right away. But looking at that operator, we can decide whether something from the collection, something from the stack, can be placed into the postfix expression that we are constructing or not. Any operator in the stack having higher precedence than the operator that we are looking at can be popped and placed into the postfix expression. Let's just follow this as rule for now, and I'll explain it later. There is only one operator in the stack and it is not having higher precedence than multiplication, so we will not pop it and place it in the postfix expression. Multiplication itself will be pushed. If an element in the stack has something on top of it, that something will always be of higher precedence. So let's move on in this expression now. Now we are at C, which is an operand, so it can simply go. Next we have an operator, subtraction. Subtraction itself cannot go, but as we had said, if there is anything on the stack having higher precedence than the operator that we are looking at, it should be popped out and should go. And the question is why? We are putting these operators in the stack. We are not placing them in the postfix expression because we are not sure whether we are done with their right operand or not. But after that operator, as soon as I am getting an operator of lower precedence, that marks the boundary of the right operand. For this multiplication operator, C is my right operand. It's this simple variable. For addition, B asterisk C is my right operand. Because subtraction has lower precedence, anything on or after that cannot be part of my right operand. Subtraction, I should say, has lower priority because of the associativity rule. If you remember the order of operation, addition and subtraction have same precedence, but the one that would occur in left would be given preference. So the idea is, anytime for an operator, if I'm getting an operator of lower priority, we can pop it from the stack and place it in the expression. Here we will first pop multiplication and place it, and then we can pop addition. And now we will push subtraction onto the stack. Let's move on now. D is an operand, so it will simply go. Next we have multiplication. There is nothing in the stack having higher precedence than multiplication, so we will pop nothing. Multiplication will go onto the stack. Next we have an operand. It will simply go. Now there are two ways in which we can find the end of right operand for an operator. A is if we get an operator of lesser precedence. B if we reach the end of the expression. Now that we have reached end of expression, we can simply pop and place these operators. So first multiplication will go and then subtraction will go. Let's quickly write pseudocode for whatever I have said so far, and then you can sit with some examples and analyze the logic. I'm going to write a function named infix to postfix that will take a string exp for expression as argument. For the sake of simplicity, let's assume that each operand or operator will be of one character only. In an actual implementation, you can assume them to be tokens of multiple characters. So in my pseudocode here, the first thing that I'll do is I'll create a stack of characters named s. Now I'll run a loop starting 0 till length of expression -1. So I'm looking at each character that can either be an operand or operator. If the character is an operand, we can append it to the postfix string. Well, actually I should have declared and initialized a string before this loop. This is the result string in which I'll be appending. Else, if expression I is operator, we need to look for operators in the stack having higher precedence. So I'll say while stack is not empty and the top of stack has higher precedence, and let's say this function has higher precedence, will take two arguments, two operators. So if the top of stack has higher precedence than the operator that we are looking at, we can append the top of stack to the result, which is the variable that will store the postfix string, and then we can pop that operator. I'm assuming that this s is some class that has these functions top and pop and empty to check whether it's empty or not. Finally, once I'm done with the popping, outside this while loop I need to push the current operator. S is an object of some class that will have these functions: stop, pop, and empty. Okay, so this is the end of my for loop. At the end of it, I may have some operators left in the stack. I'll pop these operators and append them to the postfix string. I'll use this while loop. I'll say that while the stack is not empty, append the operator at top and pop it. And finally, after this while loop, I can return the result string that will contain my postfix expression. So this is my pseudocode for whatever logic I've explained so far. In my logic, I've not taken care of parenthesis. What if my infix expression would have parenthesis like this? There will be slight change from what we were doing previously. With parenthesis, any part of the expression within parenthesis should be treated as independent complete expression in itself, and no element outside the parenthesis will influence its execution. In this expression, this part a plus b is within one parenthesis. Its execution will not be influenced by this multiplication or this subtraction, which is outside it. Similarly, this whole thing is within the outer parenthesis. So this multiplication operator outside will not have any influence on execution of this part as a whole. If parentheses are nested, inner parenthesis is sorted out or resolved first, and then only outer parenthesis can be resolved. With parenthesis, we will have some extra rules. We will still go from left to right, and we will still use stack. And let's say I'm going to write the postfix part in right here as I create it. Now while parsing, a token can be an operand, an operator, or an opening or closing of parenthesis. We will have some extra rules. I'll first tell them and then I'll explain. If it's an opening parenthesis, we can push it onto the stack. The first token here in this example is an opening parenthesis, so it will be pushed onto the stack and then we will move on. We have an opening parenthesis once again, so once again we will push it. Now we have an operand. There is no change in rule for operand. It will simply be appended to the postfix part. Next we have an operator. Remember what we were doing for operator earlier. We were looking at top of stack and popping as long as we were getting operator of higher precedence. Earlier, when we were not using parenthesis, we could go on popping and empty the stack. But now we need to look at top of stack and pop only till we get an opening parenthesis. Because if we are getting an opening parenthesis, then it's the boundary of the last opened parenthesis, and this operator does not have any influence after that, outside that. So this plus operator does not have any influence outside this opening parenthesis. I'll explain this scenario with some more examples later. Let's first understand the rule. So the rule is, if I'm seeing an operator, I need to look at the top of stack. If it's an operator of higher precedence, I can pop, and then I should look at the next stop. If it's once again an operator of higher precedence, I should pop again, but I should stop when I see an opening parenthesis. At this stage we have an opening parenthesis at top, so we do not need to look below it. Nothing will be popped anyway. Addition, however, will go onto the stack. Remember, after the whole popping game, we push the operator itself. Next we have an operand. It will go and we will move on. Next we have a closing of parenthesis. When I'm getting a closing of parenthesis, I'm getting a logical end of the last opened parenthesis. For part of the expression within that parenthesis, it's coming to the end. And remember what we were doing earlier when we were reaching the end of infix expression. We were popping all the operators out and placing them. So this time also we need to pop all the operators out, but only those operators that are part of this parenthesis that we are closing. So we need to pop all the operators until we get an opening parenthesis. I'm popping this plus and appending it. Next we have an opening of parenthesis, so I'll stop, but as last step I will pop this opening also, because we are done for this parenthesis. Okay, so the rule for closing of parenthesis is pop until you are getting an opening parenthesis, and then finally pop that particular opening parenthesis also. Let's move on now. Next we have an operator. We need to look at top of stack. It's an opening of parenthesis. This operator will simply be pushed. Next we have an operand. Next we have an operator. Once again we will look at the top. We have multiplication, which is higher precedence. So this should be popped and appended. We will look at the top again. It's an opening of parenthesis, so we should stop looking now. Minus will be pushed now. Next we have an operand. Next we have closing of parenthesis. So we need to pop until we get an opening. Minus will be appended. Finally the opening will also be popped. Next we have an operator, and this will simply go. Next we have an operand, and now we have reached the end of expression. So everything in the stack will be popped and appended. So this finally is my postfix expression. I'll take one more example and convert it to make things further clear. I want to convert this expression. I'll start at the beginning. First we have an operand, then this multiplication operator, which will simply go onto the stack. The stack right now is empty. There is nothing on the top to compare it with. Next we have an opening parenthesis, which will simply go. Next we have an operand, it will be appended. And now we move on to this addition operator. If this opening parenthesis was not there, the top of stack would have been the multiplication operator, which has higher precedence, so it would have been popped. But now we will look at the top, and it's an opening parenthesis, so we cannot look below, and we will simply have to move on. Next we have C. I missed pushing the addition operator last time. Okay, after C we have this closure, so we need to pop until we get an opening, and then we need to pop one opening also. Finally we have reached the end of expression, so everything in the stack will be popped and appended. So this finally is my postfix part, postfix form. In my pseudocode that I had written earlier, only the part within this for loop will change to take care of parenthesis. In case we have an operator, we need to look at top of the stack and pop, but only till we are getting an opening parenthesis. So I have put this extra condition in the while loop. This condition will make sure that we stop once we get an opening parenthesis. Right now in the for loop we are dealing with operand and operators. We will have two more conditions. If it's an opening of parenthesis, we should push, else if it's a closer, we can go on popping and appending. Let's say this function is opening parenthesis. We'll check whether a character is opening of parenthesis or not. In fact, we should use this function here also when I'm checking whether current token is opening or not, because it could be an opening curly brace or opening bracket also. This function will then take care. Let's say this function will take care. And similarly for this last else if, we should use this function is closing parenthesis. Okay, things are consistent now. After this while loop in the last else if, we should do one extra pop, and this extra pop will pop the opening parenthesis. And now we are done with this else if, and this is closure of my for loop. Rest of the stuff will remain same. After the for loop we can pop the leftovers and append to the string, and finally we can return. So this is my final pseudocode. You can check the description of this video for a link to real implementation, actual source code. Okay, so I'll stop here now. This is it for this lesson. Thanks for watching.